here at Austin Community College. This is experiment 22. We're going to do an electrophilic aromatic substitution reaction. We're going to add nitric acid to phenacetin. And what we're hoping to do is actually nitrate that phenacetin compound. And we're going to look at where it goes. Is it ortho-para-directing? Is it meta-directing? Where does our actual nitro group end up on our aromatic ring? This is a wonderful experiment to start OCHEM 2 with because we actually did electrophilic aromatic substitution at the end of organic 1. So it's perfect. It's a great way to start our lab. So what are we going to do? The first thing we're going to do is take our phenacetin. It's actually a nice white solid. We've got that weighed out ahead of time. We're going to add that to our Erlenmeyer flask, and then we're going to try and dissolve our phenacetin in acetic acid. Now with the phenacetin, it's kind of a fine particulate, so if I wasn't in a hood, I'd probably be wearing a mask. But since I'm in a hood, I'll be okay. And our wave outs are actually designed to transfer our solids. So I'm going to squeeze the wave out and kind of tap it a little bit to get all of those solids into my Erlenmeyer flask. Now if I were in general chemistry, I could just take some water and rinse that. But in organic chemistry, we try not to do that because a lot of our organic solvents will actually dissolve our wave out. So I'm going to go ahead and set this aside and weigh it again. That way I can subtract the weight and I know my weight accurately. So I'm going to set that aside. Okay, then in order to actually dissolve the phenacetin, I'm going to add acetic acid and I'm also going to add a stir bar. That way we can really get it stirring and warming while we're trying to dissolve. So I'll add 20 mils of acetic acid, already weighed out for us. Nice pouring technique, you pour down the side. Nice gentle pouring. Give it a little swirl. You can tell our phenacetin isn't quite dissolved, so we're going to have to work at that just a little bit. I'm going to put it on a stir plate and actually start stirring. Okay, I've placed my solution on the stirring plate. All I have is my stirring mechanism. I haven't turned the heat on yet. I'm looking to make sure that everything is dissolved. So I've got my phenacetin dissolved in acetic acid. I've stuck a thermometer in here because our next portion we're going to heat the reaction. But we don't want to heat it too hot. So we're going to keep track of our temperature. Before we do that, we need to add our last reagent, and that's our nitric acid. Now a word of caution with this experiment. Our acetic acid, yes, that's vinegar, but this is glacial acetic acid. This is pure acetic acid, as pure as you can get it. So it is a strong mixture of acetic acid. It is enough to really be an overpowering smell, and it can really burn skin. So you'll notice I'm full garb, and I've kept it in the hood. It actually is quite stinky. Now when we make our transition to nitric acid, this is also as pure as you can get nitric acid. Nitric acid is a very strong oxidizer. It is a very strong acid. It is quite powerful. It will definitely burn skin. And in fact, it's such a strong oxidizer, we don't even want to let it touch paper for very long. We do have the potential later of maybe igniting some fires with it. It is a very strong reagent. So I'm going to use it only in the hood. I'm going to use and add dropwise. I don't want to add nitric acid too fast or the reaction can blow. It can erupt like a volcano. And I don't want to get any of that on my clothes or my skin. So I'm actually going to add this nitric acid nice and slow and be quite careful with it. I'm going to add it dropwise and keep an eye on the temperature. And keep an eye for a reaction that might be getting out of control. Now what's cool is the color is changing as soon as I add that nitric acid. Now color can develop in a reaction for a couple different reasons. One of our reasons is a charged species. Now we're hoping with electrophilic aromatic substitution that we're developing an intermediate that has a charge. So that's actually a good sign when we start to see a color. Another reason we could be developing color is our product itself may have a color. So that is awesome that we are changing color so fast. And look at, we've now gone from yellow to orange. Everything is going quite nicely. We're stirring. Nothing is getting too hot. Our temperature is staying pretty good. And we're almost done adding our nitric acid. Now the next step of the procedure is to let this stir with a little bit of heat. So I'm going to go ahead and turn on the heat to about 80. And we're going to let this stir for a while. We've waited our 10 minutes. I'm going to turn off the heat and gently remove our reaction. And I'm going to add 60 mils of ice water. What I've done is actually added ice to the water bottle. That way we've got nice cold ice water. And I'm going to measure out 60 mils. Now we're adding to a really strong acid mixture. And in fact, I'm going to be extremely careful in adding this ice water. I don't expect anything to happen, but when you're dealing with really strong acids and you're adding a solution to that, you want to be extremely careful when you pour. So I'm going to pour very slow, and I'm going to tip to the side and add cautious. Nice is that our water is nice and cold, and I'm kind of pouring down the side to get anything that may have risen during our reaction. Oh, look at those crystals form. That is so cool. Still going. Watch this. It is almost solid. Look at all of those crystals just from adding that ice water. That's pretty cool. In order to calculate a % yield for this reaction, we want to make sure we've got an accurate way to measure our product. Our product will be crystals, and they are often stick to your filter paper. So I'm going to pre-weigh the weigh boat and the filter paper and record that weight. That way when we come back to dry crystals, we can weigh it again and accurately subtract the weigh boat and the weigh paper. So it looks like the weigh boat and the weigh paper okay. So now that we've formed our really bold yellow crystals, we're going to vacuum filter. Now there's, in general, several ways to filter. We're going to choose vacuum filtration because we're going to use water. We have an awful lot of water in here. Our water actually needs a little bit of help in filtering. So if you think about making coffee, it takes a while for you to actually filter and make coffee. We're going to add a little bit of help by adding vacuum, so our filtration is quite fast. If we were using an organic solvent like dichloromethane, we could just gravity filter. That's going to drip very fast. But because we're using water, we're going to go ahead and use vacuum filtration. We're also using filter paper, and it turns out filter papers are all different coarseness. We've actually picked one that's nice and in the middle. So we've got a different number for our filter paper. This is 3, right in the middle for our coarseness. All right, so I'm going to plug in the vacuum for our vacuum filtration and turn it on. filter, I typically test it. You can do that again if you feel like it. I like to make sure the vacuum is running, and I just put water in to wet the filter paper and to make sure the vacuum is running. I can tell my vacuum is running because look how fast you actually filter your water. So then I'm going to take, my goal is to get all of the crystals out of the flask and onto the filter paper. So I'm going to pour and aim for the middle. And then I want to rinse everything that's in this flask. And I'm using that ice water to do it. I don't want to use warm water in case I actually dissolve some of my crystals. So I'm going to keep the water cool and rinse it nice and several times with that cold water. I'm also going to take the opportunity to remove the stir bar. I'm going to use a magnet on a stick so that I can rinse my stir bar and try and get as many of those crystals off the stir bar as possible. Even though we've got a vacuum running, our crystals are still a little bit damp. So we're going to let those sit and really dry. We don't want to weigh our crystals now. Our percent yield would be really high. And we know that's not real because it just means your crystals are wet. So we're going to let this dry. Okay, now that we've got our crystals kind of dry, we need to get them out of our Buchner funnel and actually get them to a place that we can let them air dry for a while. We're going to let them sit in the hood and really evaporate that water. So I like to get the spatula up under the filter paper and slide that into our weigh boat. Now remember, this is what we pre-weighed. I'm going to go ahead and scrape that Buchner funnel and try and get all of those yellow crystals out as much as I can. They're a little bit sticky because they're wet, but we'll see if we can't get most of them out. Now our glassware, we're going to clean with soap and water and acetone. But our waste, we have to take care of. This waste has got very strong acids in it. This cannot go down the drain. And this can't just go in any waste container. In fact, sometimes with strong nitric acid, you can actually start to build gases in your waste container, and they can blow the top off your waste container. So we're going to be very careful when we dispose this in our waste container and actually keep our waste container slightly vented. So we make sure our waste is in the hood. And I'm going to rinse it really well into the waste container and use water and acetone. Again, none of this goes down the drain. You have to dispose of your waste properly. We don't want any of this to end up in our wastewater stream. We also don't want to dissolve our pipes or possibly hurt someone by putting the wrong waste down the drain. Okay, once we vacuum filtered, we took our crystals and we let them dry over several days in the hood. We needed to make sure all of that solvent was evaporated, and we're left with a nice dry compound as our product, our nitration product. But you can see we've got quite a few crystals. They're nice and brightly colored. It's actually really pretty. It's like a sunshine. It's so pretty. So we've taken this, and remember we pre-weighed our weigh paper, or I'm sorry, our filter paper and our weigh boat. So we've just weighed this as our crude. This is our crude product, so it'll show up on our data sheet as our crude weight. And then now we're going to do the second half of the lab, which is to recrystallize this product to purify it. So we need to get these crystals into a small 50 ml Erlenmeyer flask, and our goal is to dissolve all of these crystals in the least amount of solvent possible. In other words, we need to force our crystals to dissolve in solution. That's our next step. So it's going to take me a second to scrape these crystals into this Erlenmeyer flask, and then we'll add our solvent and heat. Oh my gosh, check this out. Our crystals are so dry, they almost look like tissue paper or crepe paper for a party. So I'm actually just going to slide that whole thing into a funnel, and I'll use my solvent to wash that down. They're almost paper, it's almost paper-like. It's pretty cool. So I can try and scrape some of this, but I'm probably going to take and use my solvent to get that into the flask. So let's see what happens when we add just a little solvent. Solvent pretty small. So I'm actually going to only take a little bit. Spill the crystal here. Crystals in here. Our goal now is to get this to dissolve. Now, in a perfect recrystallization, you'll notice this isn't dissolved. That's awesome. You don't want something that dissolves really easily. You won't get crystals back. But in this case, we're going to force this to dissolve. And one of the easiest ways to force something to dissolve is heat. So we're going to actually turn on our heat. And we're going to try and get that to a nice little gentle boil and see if we can force our crystals to dissolve in this solution. That's going to take a little while. bar in here. We don't want to add anything to the solution. And you can tell our crystals are starting to dissolve. So close. It looks like we're almost completely dissolved. Dissolved, so I'm going to remove it from heat and let it sit. Okay, we had set our product aside, and look at this. It is solid crystals. We've warmed to where we can touch it. We've cooled to where we can touch it. And as soon as we got to the right temperature, we are just full of crystals. And if you look at our solution, we have a little bit of color in there, which means we're removing some impurity. And that's the goal of recrystallization. So we're going to take this and vacuum filter like we did on the first round. I'm not going to reuse this. This has our crude product in it. We would just get it dirty again if we did that. We're going to take a fresh pre-weighed Weibo and filter paper and do our vacuum filtration again. So let me turn on the vacuum. Now what I like to do is add some ice to the water to make sure our water that we're filtering with is nice and cold. That's important. You don't want really warm water or you're going to start to redissolve your crystals. So we're going to vacuum filter with ice water. I'm going to turn on the vacuum. I like to wet the filter paper and make sure my filter is filtering. So now I'm going to go ahead and aim for the middle. And look at that color that's being removed. And rinse the flask. I'm also going to rinse the crystals with that ice cold water. Nice little rinse. And then now that our vacuum is almost done pulling, we'll let these crystals dry again over the next couple days and we'll weigh those, and this will be our final product.
104. 105. Start melting. Yeah, it's melting at 105.